intermediate. All right, and then from there, it's the second step is to collapse the intermediate. I'm just abbreviating intermediate, right? And so what you want to do, what I mean by collapse is you just reform the pi bond. Right here we have the start materials, right? We know that this is the Grignard that was added. And so when we're at the intermediate stage, we want to kick that back off. So this is going to come here, and this pair of electrons is going to go here, like so. And then that's going to give me two pieces. Right, one of those is going to look like this, right, where I have my aldehyde. And you can see that right here, I'm going to be putting a pi bond here. Right, and I'm also going to be breaking this bond right here. This app sucks. I'm leaving that on YouTube too. WPS Office. Your app sucks. All right, so we're going here plus here, right? That's what we have from that. So that's what we get from that. I'll fix that frame back in a second. But that's what we get from that transformation. So this part right here, we know once we get here, let's see if this other app is working now. Hold up. This is bad. Let me just go back to here. Excuse me. I'll just redraw this real quick and then we'll right. So again, we're going to do this set of arrows, which is going to lead to these two constituents. Right. And it's this piece right here that's going to be the Grignard. So that whatever part I release in this decomposition step, again, step one, remove H from OH, and then step two, we're going to decompose it through pi bond formation. Right, so the goal is to get back to the intermediate because retrosynthesis means we're working backwards. you get back to the intermediate, and then from that intermediate, you break it apart into its two constituents, or the two things that form it, right? So that means that for the reaction going forward, the two start materials, because that's the goal of retrosynthesis, to determine what the start materials are. The two start materials are here. And then this is the Grignard that you would add to that, right? So this that I have highlighted eventually becomes the Grignard. All right. Questions about that example? I apologize for all the tech crap, but any questions about that example?
I have a question.
Go ahead.
Can you get rid of the, is that it? Is that it for that problem?
Yes. You start at the product and work your way back to the start materials. That's what the goal of retrosynthesis is.
So you couldn't get rid of the, is that the Grignard with the other part of the,
You mean by losing this part right here?
one beside it, to the left
Oh,
of
the
it.
ring over here?
Mm-hmm.
Yeah. Yeah. But the fact that this was given already, then that's a clue as to which part is going to be the Grignard. But if you didn't have any start materials, yes, it could be the vinyl group that you used as a Grignard, or the cyclohexyl that you used. That's a great observation.
Okay.
Yep, great observation. All right, let's do this. The next one down here, number 4. All right, it's giving me this, and you can see right here, this is my start. This is the start material. Right, so what I want to do first is deprotonate the OH group to take me back to my intermediate. And if you notice up here in the intermediate, I didn't put the magnesium in, but you can. Right, it's there. So let's see down here. We're going to do this. So that's negative. The allyl group is here. CH3 is here. Now I'll go ahead and put the magnesium in so that we can just stay consistent with that. All right, now what's next? So this is step 1. So we're going to reform the intermediate. What's next?
Would you get rid of the alkyl to the right, or?
Yeah, it's given to us over here, so that's the one we're gonna take off.
Oh.
So yeah, we're gonna do this and then this, right? That's gonna leave us with this ketone plus this allylic anion. And this is obviously, when I have that, I can make that into my Grignard. Right? So the retrosynthesis part is just working backwards, trying to figure out what the two start materials are. Here, both are given, but we're going to work through some examples where they're not both given. So here, the start material would be this ketone. And it'll be that ketone plus the Grignard that's over the arrow. All right. So when we're thinking about these retrosynthesis problems, all we're doing is working backwards. Start at the product, take a hydrogen off, and then we work backwards to get to the start material. So let's look at some other examples I'm gonna assign this one for you to do on your own. We'll come back to that other example, but let's see if we can work through these examples here, and then we're going to look at some more retro synthesis examples. All right, so that first reaction, tell me what you would do there. Tell me what we're working with and what the outcome should be. What functional group is this?
Would you do elimination first,
Tell me why.
or get rid of that, break that pi bond off?
So that would be addition, right? Elimination will make a pi bond, but if you want to break it, that's addition. Yes. So you have a Grignard right here. You have a Grignard, and in the second step, you have an acid. So you know that that is that's for your quenching step. So again, when you have this functional group, which is a ketone, we know that a Grignard plus an aldehyde or a ketone equals an alcohol. So that's going to be my product. So the Grignard looks like this. Let me write it out. Well, hopefully you'll understand. Right? So there's a covalent bond between, again, magnesium and carbon. So it's this carbon, that's your nucleophile. That's going to attack that carbonyl. So even without going through the mechanism and the product, what's going to be attached to the carbonyl? Right? We know that the aromatic ring is not going anywhere. Right? We know that there's going to be an alcohol in the product because of the acetic acid quench. Right? We know that the CH3 is not going anywhere. So what am I adding to that carbonyl in this reaction? Because it is an addition of a Grignard to that carbonyl. Whoever that is snoring, just go ahead and log out. All right, go ahead. Anybody, what am I doing? What's the other piece to this product? Am I not adding this? Is that right? Right, it's the same nucleophile from here that I'm adding to that carbonyl. So if I start with a ketone, I add a Grignard to it, I'm going to get an alcohol in the product. Let's do the next one. Somebody, I need a volunteer for the next one to draw the product. Same type of reaction, right? I have a Grignard here in the first step. Second step, I have an acid to quench it with. What's my product going to look like? And I'm adding it to a ketone.
I can try it. You want me to write on the thing? Write on the screen?
Yeah, go ahead.
Okay. It'd be like this, and then is that right? Or
Mhm.
no?
No, you're right. That's the
Okay.
carbon that's going to attack the carbon that's bound to magnesium. That's the one that's going to attack the carbonyl. Yep.
And then you have the alcohol. Okay, so for this part, I don't know how to draw it, like attach.
So draw the other ethyl group, because those two groups attached to that ketone, they're not going to go anywhere.
Okay.
All you need now is a bond from the carbonyl carbon to that carbon in the chain.
Like this.
Yep. And make sure you got the right amount of, because that's a 4-carbon chain. I think you got 3. You need to add 1 more. Yes. So that's going to look like, that product is going to look like this. Right? Where you added this whole piece. That's always, I mean to write over your stuff. I thought I was over a little further. But what you're adding is that entire chain, right? Anything attached to that carbon that's bound to magnesium is going to go with that carbon. That's a question I get all the time whenever we're going over this section is, you know, what's the nucleophile and what's the electrophile? And if the nucleophile has other substituents, you know, is everything going? And the answer is yes. You can't disconnect the other carbons from that carbon. Right. And again, this is basic nucleophile electrophile chemistry. This is your electrophile. This is your nucleophile. And then with the arrows that Tia put in a second ago, right, you're going to attack here like so. And the intermediate that you get from that is going to look just like what you expect. Change colors on that. All right, so that's the intermediate. And then from there, it's just a matter of quenching. Adding in H plus to quench that intermediate and give you your product. All right. What about the second? What's different in this? I mean, not the second, the third reaction. What's different in this reaction?
It's not 1-1. It has 2 moles of the Grignard.
Good. They say the stoichiometry is different now, and so is your start material. What functional group are we working with now?
Is it ester?
So ester. Right. So what is that going to give us? If I start with an ester and I use 2 moles of Grignard, right? What does that give? What does that give us?
Would that be a ketone?
2 moles of the Grignard. I'll get a ketone if I use 1 mole.
And would it be an alcohol?
Yeah, you're going to get an alcohol. We take the ester plus 1 mole of, let me specify. And then you take an ester plus 2 moles. That's going to give you an alcohol. All right, so this is a case like the one we worked the other day where we had 2 moles of a Grignard and then a ester, And so what would the product look like? The key is to understand what the structure of the Grignard is. So you're going to actually be adding in two of these groups right here to that ketone. I mean, to the ester, I'm sorry. Right, so what would the product look like? This is not going to change. But it's going to be an alcohol. All right, and then what else? What's attached to that?
The CH3 and the CH2.
Right, at which carbon? You're right. I agree with you 100%. Which carbon?
The carbon, like it'll be to the right of the OH of the alcohol.
Yeah, no. I'm saying which carbon in the ethyl group, the CH3, CH2, which carbon is going to be attached here? You're right.
Oh, the CH2.
Yes, it'll be the CH2. There'll be two of them because you have 2 moles of that Grignard. All right, questions about that? Any questions about anything so far? Those of you who are awake. In the world. Never mind. I'll fix it later. All right, any questions?
I have a question.
Go ahead.
So we just use 1 molar of the Grignard, right?
In this problem right here,
Yeah, or is that with both? Both moles, like both moles of.
it's both. If I only use 1 mole, I'm going to get a ketone that looks like, I would get a ketone that looked like this because it would stop, right? The reaction wouldn't keep going. If I only had 1 mole of Grignard, I would just have this ketone. Right? That's all I would have. Because I wouldn't have another equivalent of Grignard to react with the ketone to give me the alcohol.
Okay.
So I would need to add an additional of the additional 1 mole of the Grignard. Right. That's how I get to that alcohol. So that's the key to the problem is recognizing the stoichiometry. If there's 2 moles of your Grignard, you're going to get an alcohol instead of the ketone. If the start material is an ester, you can't react 2 moles of that Grignard with a aldehyde or a ketone, but you can do it with an ester. And it's, again, the end goal is to make an alcohol. All of these Grignard additions to carbonyls, all of those fall under the umbrella of alcohol synthesis. It's a way to make alcohols. Pretty complex alcohols too, not just, just like ethanol or methanol. These are really complex alcohol. And anytime you employ a reaction to generate a specific functional group as the product, it always has some use. So there's always a further use of these products, you know, in a synthetic scheme, maybe for a natural product or something like that. All right. Even when you saw with those of you who did the prostaglandin assignment, well, I gave you the paper and asked you to find the steps where the Grignards were used. Every one of those Grignard reactions was like a carbonyl addition that led to a product that was a start material for a different reaction, right? So all of these things have a larger purpose. We're just kind of putting them under a microscope and looking at the individual reactions, but none of this stuff is just like in a vacuum, right? Anytime you have a reaction that's developed, there's a reason why it's developed. All right, let's look at the last two. What is that first reaction what's gonna happen there? I got magnesium, metal, in ether, 0 degrees, and I'm adding an aryl halide to it. Bromobenzene. What am I going to get from that? This is the first thing we talked about with these Grignards. I take a aryl halide, vinyl halide, or alkyl halide and stir it with magnesium metal. What should I get?
Shouldn't the MBR, MGBR, come out of it?
Yes. When you say come out, what do you mean by that? I think I agree, but I need.
No, when we were doing like the rest of the examples, I know that it always came out like as a trash product.
Oh, no. All right, so you're thinking about the actual use of a Grignard, but this is how you make them, right? You take the metal, you stir it with a alkyl halide or some halide, and this is how you make the Grignard. I can't go back to the beginning because that's a different set of notes. And it won't load for whatever reason. But yeah, this is Grignard synthesis. Right, that's how you make it. You take a alkyl halide or aryl halide or vinyl halide and stir with magnesium metal. So you make that carbon magnesium covalent bond. All right, now with the second step, what are we going to get from that? You got an aldehyde, and then you have in the second part to that reaction, HCl for a quench. What are you going to get from this? And what is it going to look like?
Would it be an alcohol?
You'll get an alcohol. I agree with that. And what would the structure of it be? Can you draw it or try to draw it?
Yeah.
Go ahead.
Do you mind? Can you zoom in?
Zoom in more.
Mm-hmm.
Is that good?
Yeah, that's fine. So all right, yeah. Mhm.
Okay. Okay.
You do the quench step. Okay, and you draw your alcohol group. And wait, I think wait. Like, hold on. Okay, wait. It'd be like, and then you draw the rest of the. Would be like this. Is that right?
Where's the CH3 group?
I
On
thought
what you
it.
just drew.
What?
Don't you need a CH3 right here on that carbon? Hold up, let me erase these other two lines. Right, what you have is you have the intermediate, but you don't have the ring added to it. Right, so yeah, you're gonna get the
Oh.
intermediate,
Oh.
but then in the quench,
Okay.
that's when you're gonna get the alcohol that you have drawn. I agree with that. But you'll get, this will be the final product.
Mm.
I'm just gonna abbreviate the double bonds in there. Right, that's what the final product should look like. I agree that it'll be alcohol though. You just didn't have the aromatic ring added.
Okay.
Mhm. I appreciate the effort though. That's good.
You're welcome.
Yeah. I'm gonna sign this one as another on your own problem. We're gonna do because it's similar to what that top problem. It's just that your start materials are a little different. We got 3 minutes left. Let's go to we're gonna do problem C down here. C and D. These are retrosynthesis problems. I'm gonna cut them out. We got 3 minutes left. We're gonna make the best of it. So let me just take that. Paste it here. All right, so it's asking, let's say for C, it's asking for 2 ways that you can make that. All right. So again, with a problem like this, what's the approach? If we know that it's a retrosynthesis problem, what's the first step that we're going to do?
Remove the hydrogen from
Remove the,
alcohol.
yes, remove this hydrogen right here to get back to the intermediate, which would look like this. And then we can throw in Mg, whatever, doesn't matter because we don't know what Grignard we used. But if you read the instructions, it says provide a retrosynthetic analysis and synthesis for each of the following alcohols, starting with the appropriate alkyl or aryl halides, right? So we're talking about Grignard addition to carbonyls, which gives us an alcohol. And if you notice, the question asks us to do this in 2 ways. It said provide 2 different ways you can do it. So what's one way? If we started with this intermediate. What's the next step in the retrosynthesis? Once we take off the H, what do we do next?
Form a pi bond.
Put the pi bond back between oxygen and carbon. That's exactly right. So when we do that, we also have to break one of the carbon-carbon bonds that's here. And since we don't know what Grignard we started with, it doesn't matter which one we break. We can break the CH3 off, or we can break off this pentyl group, isopentyl group, doesn't matter. Right? That's when it asks for two ways, that's what it's talking about. So this can decompose like this, and you end up with, and this is a, let me give you a little rule of thumb too. So if you have a secondary alcohol, that's always going to lead to an aldehyde as your start material. Right, so if I break that off, that's going to look like this. There's a hydrogen here, it's just not shown. All right, so that'll be that. And then on this side, it'll be that isopentyl group. Like that, plus CH3 minus, which we know will be, we can write it as CH3 MgBr. All right, it will be the Grignard that you will add to this aldehyde to get that product. All right, what if we did it the other way? What if we broke it like so, here and then here? Right, what would those two star materials look like? Wouldn't it be this? Yes or no?
Yes.
Yeah, and then this would become the Grignard. So I can write that like this. All right. So when it asks you to show it one way or two ways, this is what it's asking for. It's asking you to retrosynthetically analyze this compound, right? And I get in the video I sent, I gave you a strategy. Take off H, put the pi bond back, and then break one side off or break the other side off, either way. Because we don't know what Grignard we started with. So when it asks for two ways, it could be either one of those alkyl pieces can be the Grignard. Let me move this too.
Did you want to make the iodine and bromine so all be the same, or did you mean to do that?
Oh, sorry about that. No, that's not the same. Thank you for catching that. All right. So we'll do a few more of these, and then we're gonna probably take the test on Wednesday. It'll be posted on Wednesday. And then we'll start the next section as well. So since the test is on Blackboard, we'll just keep rolling. But it'll probably be posted on Wednesday. So bring this handout back with you, and then we're gonna keep working through it. And we'll finish this on Wednesday. I'm sorry, we'll finish it on Monday, and we'll start, I mean, that was next, substitution on Wednesday. All right, any questions from anybody? All right, we'll see you on Monday. God willing, have a good weekend.
Have a good weekend.
Have a good one.
All right, thank you.
Have a good one.